Radar, ballistic missiles, night vision, the internet, even duct tape. Believe it or not, they all have one thing in common: they were invented or weaponized by the US military. For over a century, the Pentagon hasn't just built weapons. It's reshaped the world, on the battlefield and far beyond it, and that legacy isn't slowing down. Right now, the US military is developing technologies so advanced, some look ripped from a sci-fi movie and others are quietly changing modern warfare in real time. From autonomous drones and underwater robots to exosuits, smart mortars and missiles that think for themselves, this is the future of military power. So, which inventions are redefining combat right now? Let's start with one of the most dominant trends in modern warfare: unmanned and autonomous vehicles. Rogue One, for example, is a next-generation, rapidly deployable, optionally lethal vertical takeoff and landing, or VTOL, small unmanned aerial systems, or SUAS. This cutting-edge loitering munition, developed by Teledyne, was unveiled in May 2024. It joins the company's other impressive SUAS, which include the Black Hornet nano drone, the Skyraider and Skyranger quadcopters, and the advanced Stormcaster sensor and targeting systems. Rogue One is designed to withstand battlefield conditions, operating beyond the reach and abilities of conventional organic weapon systems, with a focus on minimizing collateral damage and maximizing standoff capabilities. This single-operator drone offers a 30-minute flight time, speeds exceeding 70 miles per hour, and a range of more than 6 miles, even in communication and GPS-denied environments. Rogue One's fusing system features an innovative mechanical interrupt, enabling the safe recovery and reuse of the drone if targets are disengaged or missions aborted. That's very handy. Plus, it integrates advanced electro-optical technology, including FLIR Boson 640 plus thermal cameras, ensuring exceptional reconnaissance and surveillance capabilities day and night over long distances. It also features a novel coupling between sensors and warheads within the gimbaled payload, which enables super-accurate targeting. Payloads are mission-specific, modular, and can be tailored for specific target categories. This versatility gives operators the ability to conduct precision strikes against both moving and stationary armored targets, soft-skinned vehicles, and dismounted threats. Another groundbreaking US-made VTOL UAV being increasingly used around the world is the Shield AI MQ-35A VBAT. It's a full-size drone, unlike the Rogue One, weighing 125 pounds with a length of 9 feet and a wingspan of 9.7 feet. It has a maximum speed of 56 miles per hour and an altitude ceiling of 20,000 feet. What makes this drone special is that it delivers VTOL capabilities without requiring specialized infrastructure. Its compact design means it can be transported on the back of an SUV and deployed from almost anywhere. Its single-engine ducted fan propulsion system eliminates the need for launch and recovery support equipment, typical in propeller-driven VTOLs. Also, unlike most other VTOL UAVs, these aircraft navigate horizontally like fixed-wing aircraft, enhancing their operational flexibility and efficiency. They're also really versatile. The VBAT's open architecture network backbone allows integration with emerging applications and payloads, ensuring adaptability to evolving operational needs. In Ukraine, the VBAT's 112-mile range, excellent resistance against jamming, and ability to loiter for 10 hours have provided critical reconnaissance and battle assessment data. And if all that wasn't enough, autonomous teaming has also already been successfully tested. In other words, these drones can be grouped into drone swarms. And reportedly, Northrop Grumman has built a laser-guided munition called Hatchet, built on the VBAT platform, and, as of 2025, is already in production. Imagine a drone swarm of those. Sticking with cutting-edge VTOL aircraft, the Ziva Z2 looks like something straight out of a sci-fi movie. In fact, you'd probably struggle to find a slicker-looking flying saucer anywhere in this sector of the galaxy. The Z2 is a one-passenger eVTOL, or electric VTOL, aircraft that transitions from hover mode to forward flight mode and cruises comfortably at 160 miles per hour. It has a range of 50 miles and a maximum payload weight of 220 pounds. The aircraft has room for a single passenger, so it can be piloted manually. But it can also be flown by remote control, and in the future, an autonomous option will be available. The aircraft has 4 propellers at the end of its wings, 4 electric motors, and is a tail-sitter aircraft, meaning it sits vertically on its tail for takeoff and landing. Then the whole aircraft tilts forward for horizontal flight. So the pilot, or passenger when the aircraft is piloted remotely or autonomously, is in a standing position for takeoff, and then in the prone position when the aircraft transitions to forward flight. The Z2 blends the best features of a multicopter with a streamlined wing for improved range and efficiency. It's not strictly a military plane with use cases like personal air travel, first responder missions, search and rescue, police, and air cargo. However, the VTOL capabilities and ability to pick up a passenger mean it could be invaluable in getting into difficult places to execute dangerous missions, for example, to rescue wounded or trapped troops or hostages. Equally futuristic looking, but operating in a completely different domain, is the Manta Ray. It's a new class of long-duration, long-range, payload-capable UUVs, or unmanned undersea vehicles, developed by Northrop Grumman for DARPA. It's the first of a brand new class of UUVs and is designed to operate with minimal human intervention, making it suitable for military surveillance, scientific research, and commercial operations. The Manta Ray's design is inspired by the powerful ocean creature from which it takes its name. Its diamond-shaped body and wing-like fins allow it to move efficiently through the water and blend into marine environments. It features advanced propulsion systems, including buoyancy-driven gliding, which enhances its endurance and stealth capabilities. It's also modular, allowing it to be shipped in 5 standard shipping containers for easy transport and assembly in the field. Tests in early 2024 showed that the Manta Ray could glide, ascend and descend, turn, hover and anchor autonomously. But that's just a start. Development is ongoing, including novel energy management techniques, low-power underwater detection systems, mission management approaches for extended durations, and approaches to mitigating biofouling, corrosion, and material degradation. But it's not just in the air and at sea where the US is upping the ante with regard to unmanned vehicles. DARPA's Robotic Autonomy in Complex Environments with Resiliency, or RACER program, is busy developing the next generation of robotic autonomous military land vehicles. The RACER Heavy Platform, or RHP vehicles, are 12-ton, 20-foot-long, skid-steer tracked vehicles, similar in size to forthcoming robotic and optionally manned combat or fighting vehicles. The RHPs complement the 2-ton, 11-foot-long Ackerman-steered wheeled RACER fleet vehicles, or RFVs, that are already in use. These beasts are fully autonomous, powerful, fast, and made for off-road missions. They can handle highly diverse ground vegetation cover, trees, bushes, rocks, slopes, obstructed ditches, and creek crossings over a 15-square-mile area. The RHP utilizes the U.S. Army's Textron M5 base platform for robotic combat vehicles and is upfitted and supported for RACER autonomy integration hardware stacks and software by Carnegie Robotics. Currently being tested with Tactics software, once they're ready for deployment, they'll be a fearsome addition to the U.S. arsenal. They'll join the Titan UGV, a fully modular hybrid UGV or unmanned ground vehicle based on Milrem's Themis, or Tracked Hybrid Modular Infantry System. The vehicle is intended to save the lives of soldiers as it performs critical and hazardous tasks currently handled by warfighters in the combat zone. The Titan integrates the battlefield-tested robotic systems and controller from QNA and Themis UGV platform with the modular mission payload developed by Milrem and can be reconfigured to enhance mission effectiveness. The platform includes 2 track modules connected by a payload frame and measures 79 inches long, 83 inches wide, and 40 inches high. It offers a payload bay area of 72 inches by 48 inches and has a curb weight of 2,000 pounds. The maximum payload of up to 1,500 pounds typically includes an earth-moving blade and bucket, casualty evacuation litter racks, logistics support basket and truck mounts, anti-personnel obstacle breaching system mounts, a counter-improvised explosive device or CIED roller rake mount, and CIED sensing systems. The vehicle can also be interfaced with third-party payloads, such as remote weapon stations, interrogation arms, reconnaissance, surveillance, and target acquisition systems, chemical, biological, radiological, and nuclear defense, and route clearance missions. This flexibility increases efficiency while reducing lifecycle costs and soldier workload. It offers optimal off-road mobility and can be transported by helicopters, either internally or as a slung load. Speaking of injured soldiers, one of the most common injuries that U.S. troops have to contend with has nothing to do with battle. Rather, it's the scourge of lower back pain from lugging around up to 100 pounds of gear and ammunition. In fact, the Army had an average of 460 diagnoses of back overuse every day in 2019, according to the Army Public Health Center. Meanwhile, lumbar spine injuries accounted for more than 1 million lost duty days in 2018, according to military medicine. Easing that pain is the main idea behind the Sabre exoskeleton. The soldier-assistive bionic exosuit for resupply, or Sabre for short, uses passive elastic bands to take up much of the force needed to move objects that otherwise would be placed on the human body. Though it weighs just 3 pounds, this lightweight, low-profile, non-powered wearable tool reduces stress on soldiers' backs by more than 100 pounds while lifting objects, and increases their endurance by over 60%. It's not quite the Iron Man-style system that the word exoskeleton brings to mind. But making soldiers' loads that much lighter and easier to bear makes them more effective. And that might be more important while DARPA develops battle exoskeletons, especially when you consider the latest weapons US troops are being equipped with. Take the Ohio Ordnance REAPR machine gun, for example. The REAPR, which stands for Recoil Enhanced Automatic Precision Rifle, is a belt-fed medium machine gun chambered in .338 Norma Magnum, but which can be converted to NATO standard 7.62-by-51-mm. This bigger round allows it to outperform the old 7.62 NATO in every way. The 7.62 NATO throws a 147-grain round at 2,800 feet per second and has about 2,000 fewer foot-pounds of energy than the REAPR. By contrast, the REAPR is capable of chucking a 300-grain projectile 2,700 feet per second, which can pierce military-issued body armor or thin-skinned vehicles up to 620 feet away. The REAPR weighs 26.8 pounds and is 51.7 inches long. Although lighter than the M240, that's still quite a load to carry. However, the stock can fold, and the gun can break down into 3 pieces very quickly and fit in a backpack. It has a firing rate of 600 rounds per minute and utilizes a quick-change barrel system that can be swapped with a single hand. But whereas the key benefit of the REAPR is its added power and mobility, the main advantages of the Dillon Aero M134D minigun are its speed and accuracy. The accuracy is largely because the M134D is electronically driven, and thus virtually free of recoil. When properly mounted, it moves only slightly aft, without any tendency to pitch or yaw. This stability is vital in aiming and target retention, which, combined with high rates of fire and extremely dense shot grouping, allows the M134D to suppress multiple targets in short periods. When firing any weapon, especially machine guns, there is a risk of error due to movement in 3 key areas: platform, gun, and target. Movement error becomes more pronounced as the range to the target increases, but the M134D counters this by increasing the number of shots per second, thus reducing the amount of time between each observed impact. It can fire 3,000 rounds per minute, that's 50 rounds per second, with 1/50th of a second between each shot. That means it can fire 4 rounds in the time it takes an M240 to fire 1. The multi-barrel design of the M134D also ensures that each barrel only experiences a 500 rounds per minute rate of fire. This allows for repeated long bursts of fire, a barrel group life of approximately 100,000 rounds, and a system life of over 1.5 million rounds. Furthermore, in the unlikely event of a stoppage, the weapon can be serviced and made operational again in under a minute. No wonder then that the M134D or component systems are currently employed by all branches of the US military and in more than 30 countries. Unbelievable speed is also the key feature of the Scorpion mobile mortar system from Global Military Products, which offers the perfect balance between mobility and lethality. On the battlefield, repositioning frequently makes it harder for an enemy to launch an effective counterattack, and vice versa. That's where the Scorpion is a game changer. It can be loaded onto any wheeled or tracked vehicle weighing over 1.5 tons with no structural reinforcement required. Then, much like a Scorpion Stinger, the mortar system swings out of the back of the truck in an arc until it reaches its final position, with its base plate pressed against the ground. That takes roughly 30 seconds and can be initiated as soon as the truck comes to a stop. Within another 15 seconds, a skilled 2-man crew can fire the first 81 or 120mm mortar round downrange. In the first minute, the Scorpion is capable of firing 12 rounds, with the rate of fire slowing to 4 rounds per minute thereafter. More importantly, the Scorpion can be stowed and driven away a mere 21 seconds after the last shot is fired. However, the system is much more than a simple deployable mortar tube. It features a weather station that unfolds as part of the deployment to improve accuracy, and the high-tech fire control system uses double GPS units to determine the truck's location and orientation, compares that location to assigned targets, and calculates the ballistic trajectory of multiple munition types. There's also an electronics cabinet that houses control systems for the elevation and direction of the gun, communication systems, and an independent battery. That's a huge upgrade on the standard mortar system, which in many respects hasn't changed much since World War II. But it hasn't really had to, like the next item in our list, the classic landmine. But just because it doesn't need an upgrade doesn't mean it can't benefit from one. Forget the old-fashioned buried mines that resembled dinner plates or frisbees. The XM204 looks like a large suitcase, but instead of clothes, it carries 4 top-attack sub-munitions that pop up and hit the thinner armor on the top of a tank. The Army doesn't call the XM-204 a landmine, and for good reason. Mines have been widely condemned because of the harm they do to civilians even decades after they are deployed. Instead, the XM-204 is described as a wide-area top-attack munition, or a terrain-shaping obstacle. The 80-pound munition uses acoustic sensors to hear the approach of incoming tracked vehicles like tanks. Once identified, it starts tracking the target vehicle. When the vehicle is a certain distance away, the XM-204 will shoot a submunition into the air, firing the warhead down at the target within its zone of authority. By hitting the enemy from a top-down position, it not only ensures better accuracy, but also reduces the possibility of accidentally hitting friendly forces. The device itself is also equipped with a self-destruct system with a variety of settings to prevent the possibility that it will lie dormant for years after a conflict has come to an end. One of the intended uses of the XM-204 is its ability to provide sufficient defense when a small unit of soldiers is outnumbered and outmaneuvered. The group can deploy the easily portable XM-204 to help them hold down their position until reinforcements arrive. In that respect, it's like a portable minefield, and ultimately, it may replace the landmine altogether. Speaking of minefields, the US has also developed revolutionary tech for clearing them. The M58 Mine Clearing Line Charge, or MCLC. This is a rocket-projected mine-clearing line charge used to provide a close-in demining capability for the US Army and Marine Corps. It's essentially a cable fitted with explosive charges. Drawn by a rocket into a minefield, the cable lands in a straight line and then detonates, destroying conventionally fused landmines in a lane 8.75 yards wide by 109 yards long. The MCLC system consists of a trailer, a launcher assembly, an M147 firing kit, an M58A 3-line charge, and a 5-inch Mk22 Mod 4 rocket. The line charge is 350 feet long and contains 5 pounds per linear foot of C4 explosive. If it fails to detonate normally, it can be manually activated by time delay fuses every few feet along its length. The M147 firing kit can also be mounted on the M60 AVLB and the M1150 assault breacher vehicle. No doubt, given the focus on autonomous military systems these days, we'll see autonomous mine-clearing tech sooner or later. But it's not just vehicles that are going autonomous like we've already seen. Missiles are becoming autonomous too. Anduril is developing a new line of air-breathing, software-defined autonomous cruise missiles called Barracuda. The Barracuda family of weapons leverages a modular design that enables the missiles to be mass-produced at low cost and high volume. Each of the 3 variants, Barracuda 100, Barracuda 250, and Barracuda 500, varies in size, range, and payload capacity. However, all of the systems can be fitted with additional capabilities to support a range of missions and launch mechanisms. What's more, powered by Anduril's Lattice for Mission Autonomy software, the Barracuda missiles are designed to be deployed in teams. The autonomy used in the systems enables them to better understand their environment and fly in a collaborative formation with other missiles to identify targets, manage survivability, and perform complex maneuvers. Barracudas are deployable from air, ground, and maritime platforms, and are compatible with a variety of military systems, including 5th-generation aircraft, surface vessels, and MLRS launchers. Of course, with all these newfangled drones and missiles raining down, stopping them has become a crucial area of military R&D. In that regard, also from Anduril comes the Pulsar family of modular multi-mission capable electronic warfare, or EW systems. Powered by AI, Pulsar can be deployed statically on vehicles or aerial drones, from where it can rapidly identify and defeat a range of existing and future EM threats, including small and medium-sized drones. Pulsar integrates a software-defined radio, a graphics processing unit, and additional diverse computing capabilities, which allows radio frequency machine learning to identify and adapt to emerging threats at the edge quickly. This offers a range of capabilities including electronic countermeasures, counter-unmanned systems, electronic support, electronic attack, direction finding, geolocation, and other advanced EW capabilities. Pulsar's modular form factor also makes it highly adaptable. It can intelligently and autonomously scan a wider range of the electromagnetic spectrum, detect known threats and anomalous events, and significantly reduce the time needed to deploy new EW effects down to hours and days. In a similar vein to Pulsar is Leonidas, a microwave-based defense system from Epirus. It's a mobile, ground-based weapon system designed to defeat cruise missiles, UAS, and rockets using microwave transmissions. High-performance microwave signals can be adjusted to have a range of impacts, ranging from jamming devices to physically destroying electrical systems. This provides a phased array of protection for a military installation or concentration of troops. Operators focus a wide-arcing, high-powered burst of microwave energy on incoming drones that destroys their electronics, knocking them from the sky. Even better, Leonidas system upgrades can be rapidly deployed without the need for installing new hardware. This allows continuous enhancement of the system, optimizing its electromagnetic waveforms to achieve more efficient firing tactics against longer-range targets. There are dozens more jaw-dropping US military inventions we could share with you, with cutting-edge developments being announced seemingly by the day. But which of the inventions and technologies that we've presented in this video impresses you the most? Which are going to make the biggest difference on the battlefield? What radical new military technology would you like to see? Please share your thoughts in the comments below, and thanks as always for watching.